Welcome back to my YouTube channel, and in today's video we are going to do chain rule. Since the past two videos we did introduction to calculus, we are going to be adding to this table. We're adding some things to this table. This is where we stopped in our last class. So we'll be adding other things and making the table up to like maybe 10 lists. Then that will be all. So today we are going to talk about chain rule of calculus. Before we continue, please do not forget to like, share, and subscribe to my YouTube channel. Thank you. Also, turn on the notification bell so that when I post any new video, you get the information, you get the notification. So, what is chain rule? Chain rule is used when you are solving calculus or you are differentiating a function that has a power. When you are differentiating a function, ordinarily, when we have y equals to 2x squared plus 4x plus 3. When we are asked to differentiate this guy, this power will come down. We have 2 times 2. Then we now have 4. So this becomes 4x plus 4. Please, if you don't know how I differentiated this, please go back to the first two videos and you will get to understand how I differentiated this. So what if this guy was not just like this? What if this guy had a power? Now we cannot just go ahead and just differentiate inside and stuff like that, because now there's a power that affects everything here. So two ways we can do this. We can either use chain rule or we just simply open this bracket. Raised to power 3 means we'll multiply it into 3 places. And you can see already that this will be very long for us to do. So instead of us to go through that stress, we have to apply what we call chain rule. Now, how do we apply chain rule? I will be teaching the shortcuts, but let's do just this one using the normal process. This whole guy that is inside this bracket, I will give it another variable u. I'll give it another variable u. So such that if I differentiate u with respect to x, du divided by dx, I will get 4x plus 4. Differentiating this guy gives a constant. Like I said, if you don't know how I got this, please go back to the previous video. You will understand. So I've gotten du over dx. Now remember I said this guy inside this bracket, I made it u. So it is no longer this guy, it is now u raised to power 3, because I've replaced this whole thing here with u. Now I can differentiate this u, y, with respect to u. If I differentiate y with respect to u, this guy will come down. We have 3, then subtract 1 from the power. We have 2. So differentiating y with respect to u will give me dy over du. But now I observe that there's a du at the bottom here and there's a du at the top here. So that means if I do dy over du times du over dx, I'm going to get this du will cancel. I'm going to get dy over dx, which is actually what I need. So that means dy over dx is just dy over du, which is 3u squared. This is dy over du times du over dx, which is 4x plus 4. Now, what is u? Don't forget, let me write this 3 first, then 4x plus 4. Then, what is u? U is this entire guy that is inside this bracket. So, x squared plus 4x plus 3. So, this becomes my u. Then, the power here for this u is 2. So, this is the dy over dx. This is the final answer. This is the final answer. 3 open bracket, 4x plus 4. Open the bracket again, 2x squared plus 4x plus 3. Close the bracket, square. So that's it for chain rule. There's nothing hard about it. So now I just want you to observe something in this chain rule. If you observe, you will find out that without going through all this process of solving this, we can actually get this answer fast. How? Anytime you see a power in indices, make sure that power comes down and you subtract 1 from it in calculus, differentiation specifically. So 3 will come down. You can see 3 here is down. Then subtract 1 from 3, you have 2. So this guy raised to power 2, then 3 came down. But just that there's one more step you will now do. The last step is to multiply by the differentiation of this inside function. This function that is inside, will also differentiate it. That gave us 4x plus 4. So let me do a short example. Let's say we are asked to differentiate 2x plus 4, or raised to power 10. First things first, this power will come down. We have 10. Then we'll subtract 1 from the power, which will be 9. Then the last step is to differentiate this inside function. Differentiate this inside function, you get 2. So the final answer will be 10 times 2, that's 20, 20x plus 4 raised to power 9. Just like that. Very, very simple. So let's go complex. Let's say we are asked to differentiate if y is equals to sine cube x, find dy over dx. This is also chain rule, because this sine cube x actually means sine x in brackets raised to power 3. That's what it means. So this is chain rule because this guy has a power, this guy has a power. So based on the shortcut we just said, if we are to differentiate this power must come down 3, then we subtract 1 from it, right? When we subtract 1 from it, the power becomes 2. Then the last thing to do is to differentiate this inside function. If I differentiate sine, what would be my answer? Cos. Look at this table. I believe by now, after watching the first 2 videos, you would have been able to cram this. If you differentiate sine x, you should get cos x. So this will give me cos x. So my final answer is 3 cos x. Then this guy, I can just write it as sine square x, just like that. Nothing very hard, nothing complex. Let's do another example, and when we do that, we'll call it a day for this video. In our next video, we'll do more difficult examples on chain rule. All right, so let's say we are asked to differentiate this guy. Let's say y is equals to square root of 2x plus tan x. Let me say 2x squared of plus tan x. We are asked to differentiate this guy. First of all, this entire guy is inside the square root. And what is the power? What does square root means? It means raised to power 1 over 2. It means raised to power 1 over 2. So that means this whole guy has a power. So I will have to apply chain rule to differentiate this. So my dy over dx will be this. I will bring down this power, which is 1 over 2. Then I will also subtract 1 from the power. Don't forget, there's a reason why I'm giving this space. This space is to differentiate this guy and put it there. So I'll subtract 1 from that power. Then the last thing is to differentiate this inside guy. When I differentiate this guy, I'll get 2 times 2, that's 4. I'll get 4x plus sec square x. If I differentiate tan x, I'll get sec square x. Look at the table. When you differentiate tan x, you will get sec square x, just like that. So half minus 1, that will give you minus 1 over 2. So we have 4x plus sec square x. Close the bracket. We have 2x squared plus tan x raised to power minus 1 over 2. Now, in indices, like I said in I think the first or second video, like I said, in indices, we do not want a negative power. So for us to make this power negative, we have to bring it down. So this 1 over 2 is already down, so it will come down to meet 1 over 2. Because it's only this guy that is up. The 1 over 2 is, the 2 is already down. So this guy will come down so that the power becomes positive. So the power is now positive. Please do not try to open this bracket with 2. Why? There is a power here that affects everything first before this 2 can even come in. So the last thing is, in indices, we also do not want a fractional power. We also do not want a fractional power. So what does raised to power half mean? It means square root. So I will replace this thing with square root. So we have this guy plus tan x. So this becomes our final answer. So if you don't see this in the option, you may see this. Doesn't mean that this is wrong, but just that this is the way you simplify it. You may also see this. Any one of them is correct. So that will be all for chain rule. Let me quickly fill up this table with extra functions. So number 7, if you differentiate sec x. Now what is sec x? Sec x is actually 1 over sine x. Sorry, 1 over cos x. That's sec x. So let's also use chain rule to solve this guy. Let's also use chain rule to solve this guy. We want to differentiate sec x so that we'll see what our answer will be. We know that sec x, sec x is 1 over cos x. Then this 1 over cos x literally means cos x, everything raised to power minus 1. This is chain rule. There's a power, there's something inside. So power will come down, which is minus 1, times we'll subtract 1 from the power, which is minus 2, becomes minus 2, minus 1 is minus 2. Then we'll differentiate this inside function. When you differentiate cos x, you get minus sine x. Don't forget, look at this table. When you differentiate cos x, you will get minus sine x. So back to this place. So since we have gotten minus sine x, used to multiply minus 1, we'll get plus sine x. Then we have cos x raised to power minus 2. So this guy will come down. This becomes sine x all over cos x raised to power 2. Now I'm going to split this guy into 2. This is cos x times cos x. That's what cos square x means. Now, this guy, let me also split it, is sine x all over cos x. Then we now have 1 all over cos x. Now, in trigonometry, sine x all over cos x is actually tan x. Take note, if you didn't know this, sine x all over cos x is actually tan x. Then 1 over cos x is actually sec x. So that means when I differentiate sec x, I'll get tan x and sec x back. Tan x times sec x. So I'll get tan x sec x. Then number 8, when we differentiate cosec x, I would want you to try this out and tell me your answer if it will be the same as I have written here. If you differentiate cosec x is actually 1 over sine x. Take note, C to S, while S to C. So cosec x is 1 over sine x. So I want you to do the same process we did. I want you to do that and see if you will get the answer for this. This is minus cot x cosec x. And that will be all for this video. In our next video, we'll solve more questions on chain rule. We'll do this with chain rule. And solve further questions on chain rule. And in subsequent videos, we'll start doing product rule and quotient rule. Thanks for watching.